What's up, folks? Okay, so we've built our joint rectified flow image text model. I want to show you the results I got and then talk about what we would need to do to make them better. So, all right. Okay, here's a bunch of different runs I've done for different rectified flow models. Okay, here's one of the runs I kept for the joint model. So I didn't, I trained the joint model just all together. I didn't freeze anything and train anything separately, which is part of the problem. So, okay, these are after 208 epochs, these are the images that it was producing, right? And that it's not showing all the text. Oh yeah, it is. It's just all in one line and it's cut off. Oh, here you go. I just have to hover over it. Yeah, so you can see 0 is for this, 1 is for this, 2 is for this, 3 is for this, right? So I've looked through it and there's no I cannot match any of the words in the text to anything in the images. It's just garbage, right? But we can see that it's learning, at least on the image side, it's learning something more than noise, right? If we look at the train and the validation loss, it looks good. The validation loss the validation loss isn't bad. Maybe we could make it, I would like to smooth it out just a little bit. I think, maybe it's possible, So I guess let's just jump into it and just start talking about why things aren't that good, right? And I made a list, right? So first of all, the biggest thing that I think just right off the bat is the images we're shrinking down to 32 by 32, right? That's think about it on a pixel per feature level. There aren't enough pixels. There aren't enough pixels per feature, and when you shrink it down, even using anti-aliasing, which we're doing, I mean, the model is just going to learn a blob because it's gonna mix everything together, right? We need more pixels per feature, So we really need images to be on the 512 by 512 level, right? And then once you say that, you're like, well, you can't really train in pixel space anymore, right? Then you have to start moving to the stable diffusion type of latent space, right? So we need to have some kind of autoencoder KL or something that shrinks it down to 4 channels. And then now that we have 4 channels, now we need a much stronger backbone to be able to disentangle the features that are just, right? Because you're talking about, you have 4 features for 4 channels, 4 feature channels for 512 by 512 images, right? Like that's crazy compression. So that means you need a really strong backbone to be able to disentangle those interactions, right? So now we already have a much bigger model. So, okay, so now it's like, do we keep our units? Okay, if we have a stronger backbone, that means we need to add transformers at each layer, vision transformers at each layer, right? We need to add, cross attention at each layer, right? If we want it, okay, so let's just talk about the image port. Well, okay, so we're talking about making a stronger backbone, right? We'll have more layers of UNet, we'll have a deeper UNet, we'll have vision transformers at each layer, right? Or we just switch to a diffusion transformer altogether, right? Instead of using UNet. So that's as far as, I mean, you can see this thing's already blowing way out of, like, this is far past, the budget of a, well, it's far past my budget. Okay, so training it, so we need to, increase the resolution to have more features for more pixels per feature. We need to train in the image latent space. We need, okay, so then, all right, so then also, we need to train the image portion only first. Right now, it's trying to learn text. It's trying to model text and image at the same time from scratch, right? That's very challenging, right? Like to help the model learn each individual path better, you'd want to train the individual paths. So you'd freeze all the text weights and you train the image path only, right? And then after you start producing good images, after you can see, you confirm that the model is starting to learn intelligible features, then you would add the text path in. And then for the text path, right? I mean, assuming this is already coded up, right? You would just be freezing weights. Right now we just have cross attention in the mid block. We need cross attention in the lower layers of UNet, right? Or we have a diffusion transformer, right? But we need cross attention and film in more layers, right? Instead of just the mid block. And then the text path, right? Right now we're just passing an image context to learn the image context, the text velocity head, and then we're fusing it and sending it through a projection layer. What we need is cross attention. Like I mentioned in the video before, we need cross attention for the text instead of for the image. We need for the text. So we need our own text path that has cross attention. And so we'd probably add that as well at multiple layers of UNet. Yeah, and then we could use, coastline learning rates, warm up, exponential moving average on the weights for sampling, right? That would produce better samples. But I think those are less important. Those are important, but they're less important. I kind of did this in order of importance, right? Like in sort of the order of how things would cascade, right? As soon as you bump the resolution from 512 to 512 to 512 to 512, as soon as you bump the resolution to 512 by 512, everything has to change. You can't train the pixel space anymore, right? So this is really why, the model is trying to learn this Gauss. It's trying to it's like smearing these features across this Gaussian, because it doesn't have enough information per pixel, which is a very interesting concept. Anyways, so sorry, it doesn't have enough. I said it doesn't have enough information per pixel. I mean, it doesn't have enough information per feature, right? So anyways, yeah, those are some of the changes you'd want to do like immediately to start seeing intelligible results. But I think this is still an excellent project for you to walk through and do yourself. I mean, it's more than an excellent project. I mean, if you could make this run end to end without looking at a reference, just by if you can create this diagram yourself, you know what I mean? And then look at the diagram and turn that into code, you're good. You're very good, and you're in good shape. I mean, anyone is going to want someone on their team that can do that. If you can do that, you're getting close to the upper echelons of the field, So anyways, yeah, that's it. Thanks for watching. Maybe I'll add some more things to this in the future. I think I'm going to take a break for a bit. Start looking for work. I want to get back into work. I was going to add these metrics to confirm that it's actually. So yeah, let's take a look at that. So I did a text condition model. So basically it's this. So it's this model minus the text velocity head. So I'm not modeling text and image jointly. I'm just modeling the image and I'm passing in, text, instead of this FLAN T5 encoder, I'm using clip. And basically everything else is the same. So I'm trying to, basically be able to pass in a prompt and then have it generate an image. Of course, it's a toy model and I'm still constrained by compute, right? But I have a run classifier free guidance clip. What I did is, so I basically, I train the model. This is a common technique, right? I train the model by passing in image conditioning, and then I would drop out the image conditioning at a certain probability, right? So it would be producing an image without conditioning, right? And what I did was I looked at the mean squared error. I looked at the loss of three things. I looked at the loss of producing an image with conditioning, with text conditioning, without text conditioning, and then I would assign the wrong caption to the wrong image, right? And I looked at the loss of all three of those things and I compared them to each other. And what I found is that consistently there's a significant margin, although it's a bit weak, between the three values, right? So the lowest loss is conditioned, and then next comes unconditioned, and then the next comes the wrong conditioning, right? So I think it's a weak signal, right? Because the margin isn't very wide, but it's enough to say that, yes, we think that text conditioning is working, right? So anyways, yeah, that's it for the results. Let's wrap this up. Thanks for following along, folks. Later.